So yesterday we learned how to set up from exponential form to log form, and then also how to go from logarithm form to exponential form. Now we're going to learn how to solve for them. So we're going to look at questions 9 through 18. For the first four, 9 through 12, are kind of simple. Here I'm saying evaluate each expression, log base 5 of 15. All right, for starters, I'm going to say, well, this is equal to, I'm going to evaluate it. So I have to find out what this is. I'm going to say this is equal to X. So I have no idea what it is equal to. Okay, now let me set this up in exponential form. Let me rewrite this as 5 to the X. It's equal to 25. So remember, 5 was the base. We call this the base. This thing at the end is the exponent, right? We talked about this yesterday. So 5 to the X is equal to 25. Now, interesting that 25, I can rewrite this as 5 to the something. So I'm going to say 5 to the X is equal to 5 to the second, right? 25 is 5 to the second power, 5 squared. Now, because the bases are the same, I'm just going to let the exponents equal each other. So X is equal to 2. Now, there was no X to begin with, right? It doesn't say solve for X. It says evaluate each expression. I said it was equal to X. I didn't know the value. So the answer should just be 2, right? I said, let this equal to X, and I'm just going to solve for X. In this case, X is equal to 2. All right, let's take a look at another example. Question number 10. Let me rewrite this to begin with. Let me call this equal to X. And then I'm just going to say 2 to the X is equal to 1 over 64. Okay, so now there's one thing. I know 2 to the, what's this, 2 to the 5th? I know 2 to the 5th is equal to 64. Well, actually, 2 to the 6th is equal to 64. But I want this to be 1 over 64. So I have that 2 to the X is equal to 2 to the something. Let's think about this. I know 2 to the positive 6 is equal to 64. So can I just say 2 to the negative 6 is equal to 1 over 64? Remember, the negative exponent basically flip the answer. Nice. So this one I'm going to say X is equal to negative 6. All right, let's take a look at here. I'm going to say log of 7, log base 7 of 49 is equal to X. So let me write this as 7 to the X is equal to 49. Let me rewrite this as 7 to the X is equal to 7 squared, right? 49 is 7 squared. Now that I have the bases, in this case 7, the bases equal each other, I'm just going to let X equals 2. I'm going to let the exponents equal each other. So there, we solved that this is 2. One last example on these easy ones. I'm just going to rewrite this as log base of 4, 64 is equal to X. So let me write this as 4 to the X equals 64. I know 4 to the third is equal to 64. So let me write this as 4 to the X is equal to 4 to the third. So I'm just going to say X is equal to 3. Now let's change this a little, right? Let's not have it that simple all the time. Take a look at questions 13 through 18. Now here, we're going to use a calculator. Use a calculator to approximate each to the nearest thousandth. Okay. Now, nearest thousand. I expect my answer to be a decimal. Now, thousandth looks like 1,000, right? It sounds like 1,000. Thousandth sounds like 1,000. Notice how my number 1,000 has 3 zeros. I expect my answer to have 3 decimal places. Okay, so in this case, because I'm dealing thousandth, 3 decimal places. Let's take a look. To begin with, I can write this as an x, right? This is what most people will want to do. All right, 2 to the x is equal to 5.5. Now, I know 2 to the second is 4, 2 to the third is 8. So x should be somewhere between 2 and 3. I'm not going to guess, right? Especially when it's 3 decimal places. I'm not going to guess. So let me show you guys exactly how we're going to do this, right? Let's not write this in exponential form. Instead, I'm going to say what I'm going to do. I'm going to write log of 5.5 divided by log of 2. Notice I'm just doing log, so base 10. And the reason why I'm using base 10 is because our calculators, let me bring out our calculators here. You guys can see my calculator. Our calculators, I don't see log base 10. I can, in my case, I cannot change log base 2, right? Some of you guys have calculators where you guys can just type it in, log base 2 of 5.5. Now, if you have those calculators, well, you're lucky. Just go ahead and type it in. In my case, I'm going to write log of 5.5 divided by log of 2. Now, one thing we're going to do, make sure on your calculator, you're always dealing with degrees. Actually, in this one, it doesn't really matter. It doesn't matter if we deal with degrees already. And so let's do this real quick. We don't have angles here. So I'm just going to write log of 5.5. Look, when I press log, it opened log and it opened a parenthesis. So I'm just going to go 5.5 and then close parentheses. And I'm going to divide this by log of 2. Every time I press log, it opened parentheses. So make sure you close your parentheses when you finish the log. Notice I'm going to do log 5.5 divided by log of 2. Then I press enter. Boom, it gives me a long decimal place. Now remember, it said 3 decimal places. So I see 2.459. I do take a look at the next number. It's a 4. It is too small, so I'm just going to ignore it. If it was big, I will add one more. Okay, so my case is going to be 2.459. So 2.459. Let's take a look at this one. What I'm going to type in, I'm just going to go log of 5 divided by log of 2. In reality, what I'm asking here is 2 to the x is equal to 5. What's that x? But I'm going to do log of 5 divided by log of 2. All right, let's bring my calculator again. Let me clear this out. So press log of 5, close parentheses, divided by log of 2, close parentheses. I even take a look. Log of 5 divided by log of 2. Press enter. Now 2.321. But then I take a look at the next number. It's a 9. That's big enough. So this 9 will push this 1 over. So my answer should be 2.322. So 2.322. Right, this calculator, you guys have access on your homework. You guys just can click on calculator and it will give you this scientific calculator. Now for question number 15, let's just go log of 26 divided by log of 5. Let me see, I'm trying to switch here. Here, okay. Clear this out. So log of 26. Don't forget to close your parentheses. Divided by log of 5. So 2.024. The next number is too small, so just 2.024. Take a look at question number 16. Now here I'm gonna go log of 32 is equal to log of 4. Okay, so take a look at our calculator here. Clear this out. So log of 32, close parentheses, divided by log of 4. 2.5. Okay. So this is equal to 2.5. Log of 3.1. I'm just going to go log. Now, one thing, I can just type in log of 3.1 divided by log of 10. Remember I said before, when you don't see a base, that's base 10. I can type that in, or I can just type in log of 3.1. My calculator that I have, it actually does log of base 10. So I'm just going to type that in. Clear this out. Log 3.1. If we just type in log of 3.1, or we do log of 3.1 divided by log of 10, can assure you it's the same answer. In my case, it's going to be 0.491. The next number is a 3, so too small, so 0.491. And lastly, let's take a look at question number 18. Okay, now this one is ln, so natural log. Now for this one, the base is e. There's a number e, which is about 2.7. Two things. We can type in log of 29 divided by log of e. I'm going to show you guys that there is a key that says e. We can do that. Or in my case, I'm just going to type in ln of 29. So natural log. Let's take a look at our calculator here. Notice how there is an e. So I can just do log of 29 divided by log of e, or I'm just going to use this ln, which is natural log. This thing already knows that it's base e. So I'm going to say ln of 29 equals, now it gives me 3.367. The fourth number is too small, so I'm going to ignore it. So 3.367. I do expect you guys to use calculators for this part. So that is included in the homework. You guys can do that.